Welcome to the debate. Our discussion today centers on one of the most compelling narratives in the source material, the historic progression of software. It describes a really critical inflection point where applications moved from being simple, static programs to becoming these complex, intelligent systems, the foundation of modern AI agents.
Mm-hmm.
And this transformation, it raises a profound question about the history of computing. Is this a fundamental, revolutionary paradigm break? Something that changes the very nature of what software is? Or is it simply a sophisticated, necessary evolution driven by the immense constraints of scale and complexity? I'm going to argue that the introduction of learning and genuine autonomy constitutes a truly revolutionary departure.
And I think I come at it from a different way. While I fully acknowledge the transformative impact of these agent-based systems, I maintain that they are not a conceptual rupture from the algorithmic core of computing. They remain at their heart rooted in computational logic and rule-based structures. This shift is, in my view, the highest expression of software evolution, a necessary engineering response to scaling issues.
Okay, so to understand why I see this as a revolution, we have to first confront the, the inherent limitations of that previous static paradigm. Those systems were just defined by their fixed functions. The programmer had to anticipate every single possible scenario. The rigidity of that model, for me, proves it belongs to a wholly separate paradigm. Any deviation required a costly manual code rewrite. The source material even calls us out, identifying it as a conceptual shift, a turning point in computing history, precisely because agents introduced a flexibility that was thought impossible before.
But flexibility doesn't necessarily mean revolution, does it? I mean, we saw tremendous flexibility introduced with object-oriented programming, but we still categorize that as a massive architectural evolution. Where you see rupture, I see continuity. The source, even when it's describing this conceptual shift, it still grounds the agent architecture in the idea of acting autonomously based on rules and data inputs. The architecture certainly evolved, I grant you that, but the fundamental act of computational logic, processing inputs based on defined rules to get an output, that remains intact.
I have to disagree, because the core revolutionary break for me is the introduction of continuous, self-guided learning and adaptation. That capability changes the fundamental relationship between the software and its environment. Static programs, they just executed predetermined instructions regardless of context. They were brittle. An AI agent, on the other hand, is designed to learn continuously from new data streams and refine its models based on experience. The system isn't just executing, it's altering its own behavioral logic.
I see why you emphasize that self-guided element. But even the machine learning parts are described in the source not as a rupture, but as techniques embedded within them. And that framing is just crucial here. If we look underneath the hood, the entire learning process is still deterministic. It's meticulously defined, it's static code. The program doesn't invent its own logic. It executes an incredibly complex set of algorithms to adjust parameters within predefined boundaries. It's just highly sophisticated automation.
Well, your argument for evolution really falters, I think, when we look at the nature of decision-making. Autonomy is the clearest technical evidence of a revolution. I mean, think about the human interaction required. Traditional software, when it hit an unforeseen situation, it just stopped. It errored out. It required a person to intervene. An AI operations agent, by contrast, operates independently once deployed. It sees an anomaly, it orients itself to a goal like maintaining uptime, and it autonomously decides on a strategy. These are autonomous decisions based on reasoning processes akin to human cognition.
That is a compelling point, but I would challenge the premise that those decisions are truly akin to human cognition in a way that represents a philosophical break. The system's intelligence is applied to massive problems, yes, managing traffic flow in a city, for instance. But the decisions, while autonomous, are executed within the confines of internal models and operational rules defined by developers. The system is programmed with a specific goal: minimize latency, maximize profit. Its decision space is bounded by constraints and safety parameters. It's goal-driven, but the goal itself is pre-programmed.
But that definition misses the crucial difference: dynamic prioritization. If we were just talking about a massively complex flowchart, okay, that would be evolution. But agents aren't just following a path. They can adjust priorities during an ongoing process or even negotiate with other agents.
Can you elaborate on that? I mean, how is that different from what a high-performance traditional expert system could achieve?
Certainly. A complex static system might handle priorities based on pre-weighted fixed rules. Rule A always trumps rule B. A genuine AI agent introduces reactive, contextual judgment. Imagine two agents optimizing a logistics network. If Agent 1, the warehouse agent, finds unexpected congestion, it doesn't just halt. It actively negotiates with Agent 2, the transport agent, and it offers a trade-off. This is a real-time, contextually sensitive adjustment. It relies on reasoning, not just executing a pre-weighted decision matrix. That handling of ambiguity is a qualitative leap.
I grant that the complexity is orders of magnitude greater, but the reason for that complexity was deeply operational, not purely conceptual. If you look at the pain points that led to this transition, the source emphasizes the economic drivers, the costly process prone to errors, and the debilitating downtime. The whole narrative suggests that intelligent agents were the necessary scaling solution to a massive maintenance and complexity crisis. We were drowning in brittle code. Agent systems just externalize the complexity of adaptation from the programmer to the data processing loop.
I agree, the economic pressure was immense, but the constraint wasn't just maintenance cost. It was a fundamental inability to solve certain problems. The source is clear. Static programs could not easily adapt to new conditions, and they struggled with any problem that required handling ambiguity and change. Think about those early expert systems from the 80s. They were meant to mimic human expertise, but they failed because adding one new rule often broke three old ones. The knowledge base just became unmaintainable. That was rigidity.
Exactly. That failure is the clearest argument for evolution. The failure showed that the static paradigm couldn't handle the real world's complexity. So the agent paradigm is the logical, necessary correction to that failure. It's a better design that addressed the architectural strain of applying static logic to a dynamic world.
But an AI agent forecasting demand patterns, adapting its model based on real-time socioeconomic shifts, and then automatically coordinating a production ramp-up, that's not just fixing a maintenance problem. That is a completely new capability. We've moved from systems that record transactions to systems that anticipate risk and interpret sentiment. Those were previously unsolvable computational problems, and the ability to solve a new class of problems is, for me, the hallmark of a revolutionary shift.
That's an interesting point. But I frame the realization of those new capabilities a bit differently. Forecasting, sentiment analysis, these are all realized through machine learning algorithms that operate on massive data inputs. This mirrors the entire trajectory of computing evolution, continually handling larger data sets and more complex operations. Agents are simply the newest, most robust layer of enterprise software built to handle that strain of static logic in a dynamic world.
Which brings us to what I think is the most contentious point: the concept of learning versus fixed rules. If we address the learning mechanism directly, we find the strongest evidence for a paradigm break. The transition introduced the ability to learn from outcomes and improve performance with experience. This means the system is designed not just for current needs, but also for future challenges.
I understand the emphasis on the outcome, I do, but I have to press you on the process. The intelligence is embedded within the program. The source says machine learning techniques embedded within them. When we execute a training process, what's really happening? We're executing a defined optimization algorithm. Gradient descent, for example. That algorithm, the instruction set that governs the learning, is static code. We've simply evolved from fixed code that does an arithmetic task to fixed code that executes an algorithm for adaptation.
But you're focusing too heavily on the static recipe for learning, and you're ignoring the dynamic result. The recipe, the algorithm, might be static, yes, but the output of that process, the complex set of millions of weighted parameters, is the new dynamic behavioral logic of the system. That learned model is the software now, and it was generated by data interaction, not by a human writing code. It is fundamentally non-static. The code that matters, the effect of rules, is emergent, not specified.
I'm sorry, I just don't buy that the emergence of model weights constitutes a revolutionary break from computational logic. And let me tell you why. If that model drifts too far, or if the agent makes a decision outside of its constraints, the system defaults to the static safety protocols written by the developer. The programmer still defines the boundary conditions and the definition of success. The foundational framework that dictates how and why those weights change remains absolutely constant, rooted in deterministic algorithms. It's a spectacular engineering feat, but it is still software built on rules and data inputs.
And I still maintain that the move to AI agents fundamentally altered what software is. It changed it from a passive tool of execution to an active, autonomous system of understanding, deciding, and acting. Autonomy and continuous learning represent a revolutionary break from the core limitation of all previous software, its rigidity and its dependency on human intervention for any adaptation. We're in a new era where systems evolve themselves.
The narrative I draw from the material is one of brilliant, constant innovation, a clear evolution. Agent-based systems are a necessary and, frankly, clever engineering response to real operational pain caused by complexity and scale. And while they achieve levels of autonomy that were previously unattainable, their foundation in rules and computational logic demonstrates a profound continuity of paradigm. It's just the highest expression of automated intelligence today.
Well, I think both perspectives agree that organizations moving forward have to understand this historical context to appreciate the transformative role of AI today. Whether you see this as a radical new beginning or a supremely sophisticated design pattern, its impact is undeniable.
Indeed. Understanding this trajectory is critical for anyone hoping to harness this technology. And clearly there is immense depth to explore here regarding the precise architectural lines that separate adaptive programming from truly emergent intelligence. But I think that's a discussion for another time.